Hello, my name is Joe Landman. I'm CEO of Scalable Informatics, and we're here at the HPC on Wall Street Fall 2013 show and conference. And we have a number of things with us today and a number of partners in our booth that I'll just talk about briefly, and hopefully this will be interesting to most of the viewers. What we brought with us today has been our SciFlash unit, which is this unit over here. This particular unit is an SSD array on which we're running actual application code. We tightly couple computing and our storage together, which gives us unparalleled bandwidth and incredible IOP capability relative to other storage systems. And we can run our application software directly on there, which allows us to get the best of performance on these sorts of systems. And what you can see in the background on the screen right over here is that we're sustaining about 22 gigabytes a second to and from our storage unit while hitting about 400,000 IOPS simultaneously. This is 448 simultaneous reads of 32 kilobytes, and we're doing this type of test as an example of some of the performance capabilities that we have. But more typically what we do is we'll run application software directly on this. For example, our friends over at KX have a fantastic time series analytical engine called KDB+. This engine runs directly on these systems and allows us to run the actual applications at full speed without any bottlenecks whatsoever. And that in turn allows us to perform extremely well on very large scale benchmarks, such as the Stack M3 benchmarks, which we ran this preceding June. Those benchmarks, we set records in 1/3 of the tests, and we're in the top number 1 or number 2 slot in all of the rest. Our next generation tests will be coming out in several months, and we believe we will be setting some additional records with the 3.1 series. But in addition, we're also generating appliances with our friends over at Extreme Data. With Extreme Data, we have a data warehouse analytical engine system, and this particular system allows us to scale up very large-scale parallel databases running, again, directly on our hardware, and perform very large parallel SQL type operations that you would use for very large data warehouse scenarios. This is what you might traditionally use an Exadata or a Netezza type system for. We can do this in parallel at a much lower price point, much higher performance and performance density than is achievable with those systems. Thirdly, we have our friends from Lucera here with us as well, and Lucera is making use of the technologies that we create to build a financial services cloud. It's the world's first low latency on-demand cloud for trading, and these folks are building out an incredible infrastructure in order to provide world-class, fastest possible, lowest latency processing for trading applications. It's an on-demand system. It leverages a number of scalable technologies, including our SciFlash cloud node and our SciRouter system, which is a software-defined network. These sorts of systems allow them to provide unparalleled performance to their customer base, which, of course, furthers their mission in providing the best of all possible performance on large cloud systems.
So what we have here is latest generation router switch. This is what operates at the edge of the Lucera network. It was built with our partners at Scalable Informatics. This particular installation has 108 10 gig Ethernet ports in a 2U chassis. Now, what's great about this design, aside from the density, is we run Lucera's SDN stack on top of this. So this is what gives a cloud customer the ability to connect out to a financial institution with an API call. We have load balancing, we have failover, we have quality of service, all 100% software defined. There's absolutely no kit in the environment at the network level that we didn't design ourselves. It's built in tandem with the cloud compute node, which we have one of these here. So this is a traditional cloud compute node that we have at Lucera. 2 Intel 2687W CPUs, 4 10 gig Ethernet ports from 2 different vendors. We do that for redundancy. In the event that you have a failover, a failure environment at a driver level, you actually have a completely separate and segregated vendor to lean against. 128 gigs of RAM, and this plugs into the solid-state backplane. 12 solid-state drives for every single compute node, running on that Illumos flavor, that Solaris heritage. So you have a ZFS file system, free copy on write, free backups, L2 ARC for blazing fast read and write speed. We actually have customers who run on a single core and will run on the KVM and are actually doing read and write speeds at over a gigabit per second, which is just absolutely fantastic to remove that I/O bottleneck. And so these two pieces of hardware are some of the designs that are at Lucera, powering the Lucera network.